In this discussion, we will talk about solving basic trigonometric equations, and I'll also discuss the regular trigonometric equation as in second part. So here we just focus on how to write solutions to basic trigonometric equations. So we'll talk about basic trigonometric equations, and our discussion will only talk about situations where sine of x is equal to a number a, or cosine of x equals a number b, or tangent of x equal to a number c. By the way, the a, b, c are real numbers. So let's talk about the first type, which is sine of x equals a, where a is a real number. To start with, let's start with the example here. So let's say sine of x is 1/2, and I want to limit the domain or the value of the x to be between 0 to 2 pi. As you know, sine of x and cosine of x has infinitely many solutions. Now, if you either use your calculator, or if you know the value of the angle when sine is 1/2, you will know the angle will be either 30 degrees or pi over 6. So I will continue to use the radian measure throughout our discussion, although I might tell you equivalent angle measure. So the angle that will give you directly sine inverse of 1/2 equal is 30 degrees or pi over 6. Now, if you really know about the signs of the sine and cosine and tangent, sine is positive in the first quadrant as well as in the second quadrant. So between 0 and 2 pi, sine x equal 1/2 have two solutions. One of them obviously is pi over 6. We need to figure out the other solution. Of course, when you are finding the angles for trig ratios, we use an idea called reference angle. So if my reference angle is 30 degrees or pi over 6, in the second quadrant, the angle that we are talking about is supposed to be equal to pi minus pi over 6, or 180 minus 30 degrees, which is 150, or 5 pi over 6. In other words, pi x has two solutions within the given limit for the x, which is 0 and 2 pi. One of them is pi over 6, other one is 5 pi over 6. Now, if we relax the condition for the x, or if we extend our domain to go from negative infinity to positive infinity, as I said, x has several or infinitely many solutions. Now, so as you know, the first value is pi over 6, and if I go around one more circle and come back to pi over 6, or 5 pi over 6, I will have other solutions. For example, if 30 degrees is a solution to the equation, then of course 360 degrees plus 30 degrees is also solution to the equation. So if I go several times circling this, going around anti-clockwise, we will get several solutions to x. So we will arrive at two sets of values. The first set of solutions will look like pi over 6, or 2 pi, which is 360, plus pi over 6, or 4 pi plus pi over 6, and so on. The second set of solutions will be 5 pi over 6, 2 pi plus pi over 6, and 4 pi plus pi over 6, and so on. We can also extend this values to the left side as well. So if I can write a common solution for the first set, it would look like x equals 2 pi k plus pi over 6. Now the k could be any number, any real number. K could be any integer, and it could be anywhere from negative infinity to positive infinity, but only requirement here is it should be an integer. Now from the second set, we can also rewrite a common solution to this equation, which is 2 pi k plus 5 pi over 6, and again k is an integer. So generally, if sine of x equals to a, and definitely a is a number between -1 and 1, because sine of x cannot be a number more than 1 or less than -1, then x is supposed to equal 2k pi plus sine inverse of a, or x equals 2k pi plus pi minus sine inverse of a, where k is an integer. So this is called a general solution to any equation that looks like sine of x equals a number. Let's look at another example. Let me call this example 2 under sine of x equals a type. So let's call sine of x equal negative radical 3 over 2. If we use our calculator or otherwise, we know sine inverse of negative radical 3 over 2 will be equals to negative pi over 3. So using the general solution, we could write x equal either 2k pi plus or minus in this case, because plus negative pi over 3, so minus pi over 3, or x equals 2k pi plus pi minus, now since we are subtracting a negative number, it becomes positive pi over 3. In other words, this could be written as 2k pi plus 4 pi over 3. Now this is the general solution. These are the two general solutions to sine of x equal negative 3 or radical 3 over 2. Now if I plug in k equals, let's say 0, 1, 2, and you can put any number that we like. In the first solution, let me call this is the solution 1 and this is solution 2. So the first solution will tell us, if I put k is 0, I will have x equals negative pi over 3, 2 pi minus pi over 3. This is if I put k is 1. If I put k is 2, I get 4 pi minus pi over 3. So obviously negative pi over 3, 2 pi minus pi over 3 is 5 pi over 3. 4 pi minus pi over 3 is 11 pi over 3. And if I use the second solution, x supposed to equal, again I'm going to put k 0, 1, 1 and 2. So if I put 0, it's 4 pi over 3. If I put 1, I have 2 pi plus pi over 3, 4 pi over 3, and 4 pi plus 4 pi over 3. So that will work out to be 4 pi over 3, 10 pi over 3, and 16 pi over 3, and so on. So these are any of these angles. We will have, if I find the sine of these angles, I will get negative radical 3 over 2. So these two sets are basically the solution set for the given equation. Now let's talk about the second type. Let me call that is type B, where cosine of x equals to a number. Again, we like to limit the number b to be a number between negative 1 and 1 inclusive. And let's look at an example here. Let me call that as example 1 under this category. Let's say cosine of x equals radical 2 over 2, or 1 over radical of 2. And I'm going to limit, first of all, our x to be between 0 and 2 pi. As I said before, the solution to this cosine of x equal radical 2 over 2 has infinitely many solutions. So if I use the calculator or otherwise, cos inverse of 1 over radical of 2 or radical 2 over 2 will be 45 degrees of pi over 4. Now, as we know, cosine is positive in the first quadrant and fourth quadrant. So if x is in the fourth quadrant, the reference angle will be 30 degrees. So that means the angle, or the x value, will be then equals to 360 minus 45, which is 315 degrees, or x equals 7 pi over 4 in radian measure. So there are two solutions for cosine of x equal radical 2 over 2, and they are pi over 4 and 7 pi over 4. Now if I relax my x and say, okay, we wanted x to be between negative infinity to infinity, then we can look for general solution. So the first set of solutions will look like pi over 4, 2 pi plus pi over 4, to 4 pi plus pi over 4, and so on. And the second set, based on 7 pi over 4, it's supposed to be 7 pi over 4 and 2 pi plus 7 pi over 4, 4 pi plus 7 pi over 4, and so on. Now the second set could be also written as 2 pi minus pi over 4, which is same as 7 pi over 4, or 4 pi minus pi over 4, which is same as 2 pi plus 7 pi over 4, or 6 pi minus pi over 4, which is same as 4 pi plus 7 pi over 4. If I combine these two results, unlike the sign, we should be able to write x equals then 2k pi plus or minus pi over 4, where k is an integer. So k could be any number, any integer, starting from negative infinity to positive infinity. That will give various values for the x. Therefore, we can write, if we have cosine of x equals b situation, where b is a number between -1 and 1, then x equals 2k pi plus or minus cosine inverse of b, and where k is an integer. Now let's go to another example. Let me call it example 2. So let's say cosine of x equals -1/2, and again I don't want to restrict x, I just want to write the general solution. So x is anywhere between -infinity and +infinity. So if I use the above rule, x is same as 2k pi plus or minus cosine inverse of -1/2. And if I use calculator or otherwise, you will find out cosine inverse of -1/2 is same as 2 pi over 3. Therefore, x equals 2k pi plus or minus 2 pi over 3. Now, let's say if I decided to use k as 0 or 1 or 2, I will have at least 3 values for the x, 3 or more. So x will be then equals to 2k pi plus or minus, sorry about that. So if I put 0, I have x equals plus or minus 2 pi over 3. And when so this is k is 0, that will give you 2 solutions. One is 2 pi over 3, other one is -2 pi over 3. And if I put k is 1, I have x equals 2 pi plus or minus 2 pi over 3. That will give me minus will give me 4 pi over 3, or the plus will give me 8 pi over 3. And if I put k is 2, I'll get x equals 4 pi plus or minus 2 pi over 3. So either it is 12 plus 2 is 14 pi over 3, or 12 minus 2, which is 10 pi over 3. So these are at least 6 solutions to the equation cosine of x equals -1/2. Now finally, let's look at the type where tangent of x equals c. Now c is not limited here because tangent can have values between -infinity and +infinity, and the x also could be any number between -infinity and +infinity. So let's look at our first example under this discussion. Let's say tan of x equals radical of 3. And first, let's limit our x to be between 0 and 2 pi. Then we will extend our result to infinitely many solutions. So x, if I use the calculator or otherwise, I will find out tan inverse of radical of 3 equals pi over 3. Now, tangent has positive sign, the first and the third quadrant. Therefore, there will be another solution, the third quadrant, where the reference angle is pi over 3. In that case, x should be equals to pi plus pi over 3, which is 4 pi over 3. So there are 2 solutions to x when tan of x is radical of 3 between 0 and 2 pi. Now, I can extend this and write several other solutions like the way we did before, and you will find out x will be, if I just have tan of x equals c with unlimited domain, negative infinity to positive infinity, then x will be equal to k pi plus pi over 3, where k is again an integer. So if I again, as I was doing previously, if I put k 0 or 1 or 2, at least we could find 3 solutions. One of them will be x equals, when I put k 0, I'll get x equals pi over 3, which is very much obvious. When I put k is 1, I will get x equals pi plus pi over 3, which is in fact 4 pi over 3. And if I put k is 3, I will get x equals, sorry, k is 2, I will get x equals 2 pi plus pi over 3, which is 7 pi over 3, and so on. Let's again look at another example. I'm going to call this second example under the tangent values. So let's call tangent of x equals negative 1. So if I use our calculator otherwise, we will find out tan inverse of negative 1 equals negative pi over 4. So according to our discussion, x must be equal to k pi minus pi over 4 because the angle is negative here. And if I, let's say if I put k is, this time I'm going to put negative 1, 0, 1, 2 and so on. So if I put k is negative 1, I will have x equals negative pi minus pi over 4, which is same as negative 5 pi over 4. If I use k is 0, I'll get x equals negative pi over 4. Then if I put k is 1, I get x equals pi minus pi over 4, which is same as 3 pi over 4. And if I put k is 2, I will get x equals 2 pi minus pi over 4, which is same as 7 pi over 4, and so on. So there are several solutions, but at least I wrote 4 of them for the type tangent of x equals negative 1. So let's summarize what we did so far. So if I have sine of x equals to a number a, then x equals 2k pi plus sine inverse of a, or x equals 2k pi plus pi minus sine inverse of a. And if I have cosine of x equals to a number, let me call that as b, x supposed to equal then 2k pi plus or minus cos inverse of b. And if I have tangent of x equals to a number c, then x equals k pi plus tan inverse of c. Now in all of those situations, k is an integer. Once we know how to solve sine x is a number, cosine of x is a number, tan x is a number, then we can always solve equations such as cosecant of x is some kind of number, let's say d, or secant of x equals e, or cotangent of x equals f, and so on, because we do know if cosecant of x is d, sine of x supposed to be 1 over d. So we can convert them to sine, cosine, tangent and solve those equations instead.